Hello everyone, welcome to the 11th video on Snowpro core certification series. In this video, we are going to discuss about various authentication mechanisms within Snowflake, which involves MFA, federated way of authentication, Keypair way of authentication, single sign-on, and also we are going to discuss about network policies in detail. Without further ado, let's see what are all the important details which are associated at the part of this specific section. First thing, we are going to look at general things about the Snowflake users. Say I am a user in a Snowflake system. What are all the things which are needed? First thing is all about the user creation. The user creation can be done by multiple ways. Typically, we will be using SQL. Administrators can perform all the user related tasks, including changing the login credentials or the defaults for the users, whatever it is, using the SQLs. Snowsite also supports lots of user related tasks. Typically, for creation of the user, you need to have the user admin privilege. So ideally, user admin system role can create the users using the SQL, usually using the create user command. Modifying the user can always be done using the alter user command, which needs the ownership privilege on the user or the higher role. Higher role in the sense, user admin can also be used to modify the user properties using the SQL, using alter user. In addition to that, the role must have the global create user privilege. This is all about what are all the privileges which are needed for you to create the user in the Snowflake. Moving on about the password policies. A password policy specifies the requirements that must be met to create and reset the password to authenticate to the Snowflake. There are currently two options which are available. One is the built-in password policy to facilitate the initial user provisioning process, but always a schema level password policy object can also be set at the level of the Snowflake account. An individual user or both depending on the use cases and needs of the user administrator. So by default, we are having the built-in password policy which is available within the Snowflake, but always we can set the schema level password policy. Moving on to the built-in password policy which we discussed earlier, these are all the specific set of requirements which is provided by the Snowflake if we are using the built-in password policy. So it can be a case sensitive string of 256 characters including blank spaces, a special non-alphanumeric characters such as the explanation points, percentage signs and asterisks. These are all the things which needs to be added as the part of the password. It must be minimal of 8 characters long, must contain at least one digit, must contain at least one uppercase letter and one lowercase letter. These are all just the information for you. In the exam, they may ask some questions related to this. In the built-in password policy of Snowflake, what are all the minimum requirements? Like that, for that to answer that specific kind of a question, you need a basic understanding on what are all the things which are available as the part of the built-in password policy. Now we are going to discuss about multi-factor authentication. Most of us might be aware of what is MFA. In fact, we are using MFA in our day-to-day life. Say for logging into any system, nowadays most of the systems are enabled with multi-factor authentication to provide an initial understanding on what MFA is all about. I just put together this thing. MFA is as simple as it is: something you know, something you have, something you are. So something you know can be a password or a pin or any sorts of the pin mechanisms there. Something you have is something like a bracelet or a key fob or a mobile phone or the other devices. Typically, we will be using the mobile phones and the passwords. So the MFAs is all about once you enter your password there, and then it will ask for the keyword from your authenticator. It can be a Google authenticator, it can be a Microsoft authenticator. Using mobile phones, we will get that key and then we will pass on that key. So by doing so, something you know is the password, something you have is the mobile phone. So two factors of authentication we are giving. This will give more more security. So what MFA is all about? MFA reduces the risk of security breaches occurring and keeps the data very safe. In the past, requiring a static username and password to access the account seemed sufficient for security. But if a password is getting stolen by somebody knows your password, then everything will be breached off, right? So fraud attacks and data breaches, when only one form of the authentication is required. In order to overcome these sorts of problems, MFA got introduced. MFA to bolster password security with another form of the authentication, as we already discussed. Another form is something you have in the form of the mobile phone, is proven to keep it from the hackers. So as per the Microsoft, MFA can prevent 99.9% of the attacks from your accounts. Most of the systems are currently using the multi-factor authentication. Now coming to Snowflake, how the MFA can be implemented in Snowflake. In Snowflake, we can implement MFA using a system called DO security service. This is just the mobile app we are going to discuss. Snowflake supports the multi-factor authentication to provide increased login security for users connecting to Snowflake, a known thing which we already discussed. MFA support is provided as an integrated software feature provided by the DO security service, which is managed completely by Snowflake. This is the screenshot which I took from my mobile actually. So if you can see, this is the Android based application which I can install on my mobile, and then you can configure the MFA on that specific device. Just to do install of the DO application on the mobile, as simple as it is, MFA is enabled on the per user basis. So it can be enabled on per user basis. Currently users are not automatically enrolled for MFA. User must have to enroll themselves. Snowflake strongly recommends all the users who are having the account admin role must be enabled with the MFA for the additional level of security. Now we are going to discuss about the MFA flow, how the flow it looks like. Just go through this diagram. In the Snowflake interface, we will enter the Snowflake credentials first. This is the first mechanism which we do. Once you enter the credentials, it will go to the second factor device, which is in turn a mobile which contains the DO application which is installed. So you can have multiple ways by which you can authenticate. One is via the push notification. You will get a push message and you can just click on allow, automatically it will be allowed. You will do a call me, it will give a call to you. So by attending that call as well, you can authenticate, and then you can enter a passcode. This is the most used the way of connecting to Snowflake or any other application. As I mentioned, the authenticator service, Google Authenticator or Microsoft Authenticator, you will get the password there and then you will enter the password as the second factor. Once you do all these things, your login will be successful. So as simple as it is, the process is very seamless compared to all the other applications. Now we are going to discuss about some of the key factors about the MFA. Say, consider this scenario. If a user loses their phone or changes their phone number and cannot log in with MFA. Say, considering the fact that I had already enrolled for the MFA, but I lost my phone or I changed my phone number. Now what can I do? There are multiple ways Snowflake is providing us to rectify this problem using the alter user command. What we can do is minutes to bypass MFA is one option. By doing this, say like an account admin or so, they can go and they can do the alter user command and they will do minutes to bypass MFA as some seconds value or some minutes value. Say I can do minutes to bypass MFA as 10 minutes. By doing so, what it happens, for 10 minutes for that specific user, the MFA will be disabled. Specify the number of minutes to temporarily disable the MFA for the user so that they can log in without the MFA. After the time passes, MFA is enforced and the user cannot log in without the temporary token generated by the DO mobile application. As simple as it is, if you want to bypass the MFA for some amount of time, minutes to bypass MFA is one of the options. Disable MFA, I hope you understand by the name itself. If you want to completely disable the MFA, you can do it using the disable MFA command. And then the third one is allow client MFA caching. This is all about caching the MFA tokens in the Snowflake. Instead of providing the MFA tokens for multiple times, you can cache the MFA tokens within the Snowflake system. The maximum caching period is for 4 hours. You can see these commands here. As we already discussed, minutes to bypass is equal to 10. This will bypass the user 1 MFA for 10 minutes. So user 1 can log into Snowflake without MFA for 10 minutes. Alter user 1 set disable MFA to true. This will completely disable the multi-factor authentication for user 1. This specific allow client MFA caching is set at the account level. So alter account set allow client MFA caching to true. This will cache the MFA token for close to around 4 hours. Now we are going to discuss about federated authentication and SSO within Snowflake. Again, a known topic. If you are into the IT field, you might be aware of what the federated authentication is all about. It is as simple as it is. The user management is handled by a separate external system. We used to say that as the IDP. Typically, that system will take care of all your user management, and it will provide the federated way of authentication into Snowflake. In Snowflake, we can have the option of using the same mechanisms. This is more or less same with the SSO as well, which we call it as the single sign-on. Using the single username and password, you can have the access to all the systems. So the SSA, SSO and the federated authentication will work hand in hand. User authentication is separated from the user access using one or more external entities that provide the independent authentication of user credentials. That is what the federated authentication is all about. The authentication is then passed to one or more services, enabling user to access the services through SSO. This is the federated authentication is all about. So you can just see this picture. We will discuss about this picture in quite some time. First, let us see the basic things here. The federated environment consists of two following components. That is very important to note. First is the service provider. In this case, in the Snowflake case, the service provider is always Snowflake, as simple as it is. The second one is the identity provider. This is the external entity which is responsible for creating and maintaining the user credentials and other the profile information, authentication for users, SSO access, everything is handled by the identity provider, which is external to the Snowflake. So what are all the identity providers which are commonly available? Snowflake natively supports Okta and Microsoft ADFS, which is the Active Directory Federation Services, which is very well known form of the IDPs which is available currently in market. So Okta and Microsoft ADFS are the native IDPs which is supported by Snowflake. In addition to the native IDPs, Snowflake supports SAML 2.0 compliant vendors such as Google G Suite, Microsoft Azure AD, and then OneLogging, and then Ping Federate, Ping 1 as well. So please understand these things. These are all the IDPs which are currently supported by Snowflake. You might be asked about these details as a question in the exam. Now, for the understanding perspective, I just put together, this is the federated communication of Power BI to Snowflake. How a Power BI service which is sitting here can communicate to Snowflake via federated thing. Here the Azure AD is acting as the federated identity or the IDP, identity provider. First, what it happens, the Power BI will do the authentication with Azure AD. Azure AD, this is optional IDP, which is Azure AD only. So it will do the SAML authentication, and then it will pass the token to the Power BI again. So Power BI authenticates to Azure AD. The Azure AD will provide the token. Using that token, it will connect to the Snowflake. What the Snowflake does, it will do the trust identification between the Azure AD. Automatically, it will integrate that token and it will get the credentials and everything. And then it will establish the DB session and it will give it back to the Power BI service. By doing so, Power BI can smoothly communicate with Snowflake using the federated identity of Azure Active Directory. Now we are going to discuss about Keypair authentication within Snowflake. This is quite an interesting topic, but out of scope from the exam point of view or from the course point of view, understanding what Keypair authentication is all about. But for the better knowledge and for your better understanding, I am just trying to provide some information about the Keypair authentication. What the Keypair authentication is all about? It is all about asymmetric way of communication between two users. Asymmetric way means asymmetric keys actually. So It's a Keypair authentication for enhanced authentication security as an alternate to the basic way of authentication such as the username and password. Instead of using username and password, we can use Keypair based authentication as well. This is one good diagram which I got from one of the blog. I am going to show that to you. For better understanding, let me jump onto that blog first and then we will see how it works. This is that blog which I am talking about, which is a very fantastic blog which is written by Naman Gupta. How SSL works. SSL is the secured socket layer. So now you can see this is the symmetric encryption, meaning what? There is a sender Bob who is sending a plain text data that is encrypted using a shared key. So once the data got encrypted, that is called as the ciphered data, and then what the sender side, receiver side, what they will do, they will use the same shared key to decrypt the data, and the allies, recipient allies can see the data. Now Bob is sending the information to allies using the shared key. He is encrypting it and sending it. Now the problem is, what if an hacker sits in the middle? He or she is having the access to the shared key. They can very well access this ciphered data. Now this is the problem with this symmetric type of encryption. In order to overcome that, we came up with the another approach which we call it as the asymmetric encryption. Asymmetric encryption uses two keys. Instead of using one shared key, it uses two keys. In fact, all the things, whatever which we are doing, right, the HTTPS, whatever which we are doing using the internet is all done using the same. Here you are seeing it, right? Connection is secure. Whatever the certificate is valid. That is how it works. So public key and private key. What it happens to be, public key is the only key which is shared with all the users. In the case of the HTTPS, say if you are using a banking website, say your username and password, if you are entering it, if it is going in the plain text, hacker gets the username and password, that's it. It's a complete security breach. How they are overcoming it? Overcoming it using the asymmetric way of encryption. So only public key will be shared to you. Whatever using that public key, you will encrypt the data and you will be sending it. But with the help of the private key alone, you can decrypt that encrypted data. Now a hacker is sitting here, he get hold of this public key. With this public key alone, he cannot do anything. Public key can only be used for encryption. For the decryption purpose, they need the private key. Private key is available only with the providers, meaning the banking website, banking service is having the private key. So using that private key, they will do the decryption and they will see the data. This is what we call it as the asymmetric way of encryption. That is very important to know from this perspective. Here also we are doing the same picture which I took from that blog. I am putting it here. Now these two keys of public key and private key, we call it as an key pair actually. So without the private key, you cannot decrypt the data. Without the public key as well, you cannot encrypt the data. So what is the procedure which we used to follow from Snowflake? As simple as it is, first we need to generate the private key using OpenSSL. I will be adding the description of complete Snowflake documentation which provides all the steps of procedures there. So it will be available as the part of the description of this video. But this is the sequential step which we need to follow. First we need to generate the private key, followed by we need to generate the public key. We need to store the private and public keys in a secure place and then assign the public key to the Snowflake user. As simple as it is, verify user's public key fingerprint and then configure Snowflake client to use the Keypair authentication. Then optionally we can do, this is the optional process, optionally we can do the Keypair rotation as well. Most of the companies, for the security reasons, we need to rotate the key pairs on a regular interval, say like at 2 months or 3 months or 6 months or so. So this is the typical procedure or the process steps which we need to follow for the Keypair authentication within the Snowflake. Now we are going to discuss about network policy within Snowflake. Quite an interesting topic to discuss. Please pay more attention towards this specific topic. You can also expect some decent amount of questions in the exam from this topic as well. A network policy, what a network policy is all about? It is all about a firewall mechanism which we can implement within the Snowflake. What is a firewall? Firewall meaning what? We can allow something, we can deny something, as simple as it is, right? So a security administrator can use the network policy to allow or deny access to the request based on its origin. That is very important. Origin can be of any form. Origin can be of a IP address, origin can be of a region, origin can be of anything. We can specify many sorts of things as an origin. It is working with two basic principles. One is the allowed list, another one is the blocked list. As simple as it is, the name is self-explanatory. Allowed list controls which requesters are allowed to access the Snowflake service or internal stages. Blocked list in the similar way controls the request which needs to be explicitly blocked. Now, how we can manage these two things is via a network policy. In the older version of Snowflake, not older version I would say, in previous days, we can directly specify these allowed list and blocked list as the part of the network policy. But now Snowflake is recommending something called as the network rule. Instead of directly specifying it under network policy, we can create network rules and then we can attach the network rules as the part of the network policy. We are going to see it subsequently. So a network policy does not directly specify the network identifiers in the allowed list or blocked list. Rather, a network policy adds network rules to its allowed and blocked list. As I mentioned earlier, it is a new feature within Snowflake. You might be asked in exam that directly specifying the allow and blocked list in network policy is also valid. What Snowflake is telling, whatever which we are going to use after this, we must have to utilize network rules. If it is in the previous version, previous thing, if you already defined your network policy with allowed and blocked list, it will work fine. So both the things work fine, but now onwards we must have to use the network rules. So what is the procedure? As simple as it is, first we need to create the network rule. Second, we need to create one or more network policies that includes the networking rules. And then finally, we need to activate the network policy for an account or an user or the security integration. Very simple, 3-step procedure. Now, here we are seeing creation of the network rule. Here we are creating a allow access rule, which is the mode of ingress. Ingress meaning incoming traffic, type of IPv4. This is the CIDR block. So 256 addresses, 192.168.1.0, it will go till 256 actually. So /24 is the CIDR block. So all the things which are coming under 192.168.1.0 till 256 will be allowed as the part of this rule. Now we are creating the block access rule. Here again ingress, here we are denying the 99 IP address only. Meaning what? It is like this specific IP address is part of the block access rule. So currently we just created the network rules alone. Now we are creating a network policy and we are adding these two rules here. Allowed network rule list, allow access rule, block network rule list, block access rule. Now what we are trying to say, all these 256 addresses are allowed. Within that, this 99 alone is not allowed, and we created a network policy based on these two network rules. Now we are associating this network policy to multiple things. You can associate this network policy to an account. Here you can see alter account set network policy equal to my policy. This is a different name. This is the public network policy is the name, must have to be entered here, right? And then alter user as well. You can associate it at the account level. You can associate it at the user level using the same, and then you can associate it at the security integration level as well using this one. So the same 3-step procedure, we just seeing the examples here for your better understanding purpose. Now the network policy precedence. Now we saw 3 things: account level, user level, storage integration level. What if I am having a network policy which is associated at all 3 levels? Which takes more precedence? It's a very natural question. So this is how the Snowflake is telling. First thing, it will take the account level. Account level is always overridden by storage integration level, which is always overridden by user level. So I hope you got the idea here. So the user level takes the most precedence. Even if it is allowed or blocked at the account level, the user level will override all these precedence. This is the typical network policy precedence which you might be aware of. So attaching a network policy for an account enforces the policy for all the users in the account. As simple as it that is, it's an top down approach. So whatever associated with the account, if you attach a network policy for that specific account, it will be applied to all the users. Only security admins, meaning security admin role or higher role, that has the attach policy privilege, can activate a network policy for an account. This is another important thing to know. You can create multiple network policies. However, only one network policy can be associated with the account at any one time. Meaning what? For one account at any point in time, only one network policy can be attached. Only single network policy can be attached to each user at a time. Again, the same logic we are applying. At one point in time, only one network policy can be attached to user as well. Now these are all something how I can identify a network policy which is associated at the account level. You can use the show parameters command. Show parameters like network policy in account, it will give you all the network policies which are activated at the account level. Similarly, you can find it at the user level as well using the show parameters command. Show parameters like network policy in user JSmith. So for the user JSmith, what are all the network policies which are associated will be automatically given out as the part of this command. Just remember the show parameters, that is very important to identify the network policy which is associated to account or the user. With this, we come to end of this video. Same thing, I will add all the Snowflake documentation link as the part of the description of this video for your easy reference. Just glib through all this documentation. I add the SSL blog link as well in the description. Please go through those things. That will enhance your foundation to a greater extent. I hope this video has been informative for you. Please do write lot of comments. That is very much required for me to enhance my course contents. Thank you very much for watching this video.